Chapter 1 Number Systems. Children, in your previous classes, you have learned about the number line and how to represent various types of numbers on it. See, this is called a number line. Already we studied about natural numbers, whole numbers, and rational numbers. Now just we recall it. Okay, children? The collection of natural numbers which is denoted by the symbol capital N. The collection of whole numbers which is denoted by the symbol W. The collection of all integers is denoted by the symbol W. The collection of rational numbers is denoted by Q. Here means in this rational numbers, rational comes from the word ratio and Q comes from the word quotient. Rational numbers. Here rational comes from the word ratio. Once again I repeat it. And Q comes the word quotient. Children, you may recall the definition of rational numbers. See the chart. This is the number line. Here natural numbers. We can mark natural numbers, whole numbers as well as rational numbers on the number line. Definition of rational numbers. A number R is called a rational number if it can be written in the form P divided by Q, where P and Q are integers and Q is not equal to 0. Already I told you about the symbols. Natural numbers denoted by N, whole numbers denoted by W, all integers denoted by Z. All means positive and negative included with this. Rational numbers denoted by Q. One more thing, in this rational numbers, one more thing is important, that is equivalent rational numbers. For example, take one number, that is 1 divided by 2. See, 1 divided by 2 is equal to 2 divided by 4. That is equal to 10 divided by 20. That is equal to 25 divided by 50. That is also equal to 47 divided by 94. These are called equivalent rational numbers. Example 1. Let us see example 1. Are the following statements true or false? Give reasons for your answer. Every whole number is a natural number. It is false because 0 is a whole number but not a natural number. Here they give every whole number is a natural number. This is wrong statement. So this is false. Reason for wrong answer, because 0 is a whole number but not a natural number. Next one, every integer is a rational number. Yes, it is true only because every integer m can be expressed in the form m divided by 1, and so it is a rational number. For example, take any one integer like 25. Yes, 25 is a integer only. 25 is equal to 25 divided by 1. So then that is also a rational number only. Every rational number is an integer. This statement is false because, for example, 3 by 5 is not an integer. So in this case, the given statement is false. Example 2. Find 5 rational numbers between 1 and 2. Here we can approach this problem in at least 2 ways, children. First way, recall that to find a rational number between R and S, you can add R and S and divide it by 2. Divide the sum by 2. That is R plus S. Here R and S, given rational numbers. The sum of given rational numbers divided by 2 lies between R and S. See, find 5 rational numbers between 1 and 2. First, add 1 and 2. 1 plus 2 is equal to 3. That is whole divided by 2. So 3 by 2. You can proceed in this manner to find other rational numbers also. Now, 5 rational numbers between 1 and 2 are 5 by 4, 11 by 8, 13 by 8 and 7 by 4. These are all the rational numbers in between given numbers. In another way, next method, find 5 rational numbers between 1 and 2. 1 and 2. We need 5 rational numbers. So, denominator is 5 plus 1. Here we will take denominator is 5 plus 1. Here 5 plus 1 is equal to 6. So, when we will get 6 is divided by 6, then only we will get 1. So, 1 is equal to 6 by 6 and 12 by 6 is equal to 2. So, 1 is equal to 6 by 6 and 2 is equal to 12 by 6. In between these numbers, required rational numbers are there. That is 7 by 6, 8 by 6, 9 by 6, 10 by 6 and 11 by 6. If in these numbers cancelling is applicable, you simplify the numbers, then after you write. After simplifying, between 1 and 2, the 5 rational numbers are 7 by 6, 4 by 3, 8 by 6 is equal to 4 by 3, 9 by 6 is equal to 3 by 2, 10 by 6 is equal to 5 by 3, 11 divided by 6, there is no possible to divide. So write it as same. Now we will go to exercise, children. Exercise. Before exercise, one more important thing is there. Here we saw 5 rational numbers between 1 and 2, isn't it? But not only 5. Generally, there are infinitely many rational numbers between any two given rational numbers, children. Yes, always in general there are infinitely many rational numbers between any two given rational numbers. Exercise 1.1. First question. Is 0 a rational number? Can you write it in the form P divided by Q, where P and Q are integers and Q is not equal to 0? Answer for this problem. Yes, 0 is a rational number only, because it can be written in the form of P divided by Q. Yes, for example, 0 divided by 1, 0 divided by 2, 0 divided by 3, 0 divided by 4, 0 divided by 5. These are all the rational numbers where P and Q are integers and Q is not equal to 0. This condition is satisfied here. See, take this first example, 0 divided by 1. Here P is 0, Q is 1. This condition is Q is not equal to 0. In this term, Q is 1 only. That is not equal to 0. Numerator is 0. That is integer only. So, 0 is a rational number. It can be written in the form P by Q. It is true. Second problem. Find 6 rational numbers between 3 and 4. Already we saw the example. That same model only. Example 2 model only. Here we need 6 rational numbers. Already we saw find 5 rational numbers. 6 rational numbers we need in between 3 and 4. Here we need 6 rational numbers, isn't it? So the denominator is 6 plus 1. 6 plus 1 is equal to 7. First number 3. How can you write 3 with denominator 7? Equal to 21 divided by 7 is equal to 3. 3 is equal to 21 divided by 7. Denominator 7. How to write 4? With the use of denominator 7. 28 divided by 7. 28 divided by 7 is equal to 4. So here 3 is equal to 21 by 7 and 4 is equal to 28 by 7. In between these two rational numbers, 6 rational numbers we need. They are, after 21 by 7, 22 by 7, 23 by 7, 24 by 7, 25 by 7, 26 by 7 and 27 by 7. These are all in between rational numbers. for 3 and 4. Next one, that's means third question. Find 5 rational numbers between 3 divided by 5 and 4 divided by 5. See children, as same as second problem, 3 divided by 5 is equal to 30 by 50. How is it possible? 3 tenths are 30, 5 tenths are 50. Numerator 3 and denominator 5. Both numbers are multiplied by 10. So we got 30 by 50. Next number 4 by 5. This one also multiplied by numerator and denominator by 10. 4 into 10 is equal to 40. 5 into 10 is equal to 50. Here the number 3 by 5 is equal to 30 by 50. 4 divided by 5 is equal to 40 divided by 50. So we can select the in-between numbers in between 30 by 50 and 40 by 50. Hence 5 rational numbers between 3 and 5, 3 divided by 5 and 4 divided by 5 are 31 by 50, 32 by 50, 33 by 50, 34 by 50 and 35 divided by 50. If cancelling is possible here, do the simplification. After that, we will get 31 by 50. 32 by 50 is equal to 16 divided by 25. 33 divided by 50, write it as same. 34 divided by 50. Simplification is possible here. So do the simplification. After that, we will get 17 divided by 25. And 35 by 50 also. Simplest form, 7 divided by 10. 35 divided by 50 is written into 7 by 10. Fourth question. State whether the following statements are true or false. Give reasons for your answers. First one. Every natural number is a whole number. This is true only. Right statement. Yes, this is true. As whole number is the collection of natural numbers and 0. So the given statement is, first statement is true. Second statement, every integer is a whole number. This statement is false statement only because negative integers are not whole numbers. In whole numbers, only positive values only. But here they gave every integer is a whole number. That is false only. Negative integers are not whole numbers. So the statement is false. Next one. Every rational number is a whole number. This statement also wrong statement only. So answer is false. Rational numbers like 3 divided by 5, 2 divided by 3, 7 divided by 9 are not whole numbers. So in this case, the statement is not applicable, children. Concept. We learned natural numbers, whole numbers, rational numbers, And definition for rational numbers: pattern of number line, symbols for natural numbers, whole numbers, integers, everything children, as well as equivalent rational numbers, equivalent form of rational numbers, and how to find in between rational numbers, that is how to find in between rational numbers for given two numbers.